Hi, my name is Mauricio Alcalá, and my team is composed by José, Eugenio, and Enrique Navarrete, and we are going to do an experiment that is related to static friction. And first, I'm going to give you an introduction, and I'm going to bring you the definition of static friction. Static friction is the friction that exists between a stationary object and the surface on which it's resting. Once the objects have already started moving, kinetic friction takes over. This is the friction that exists between two objects moving relative to each other. Kinetic friction isn't as strong as static friction, and so it's easier to keep the shopping cart moving. Now I'm going to talk about the inequality for static friction. Force is a push or pull measured in newtons, and friction is one such force. We can calculate how many newtons of frictional force there are between two surfaces using this inequality. The coefficient of friction is just a number that represents how much two surfaces grip each other. The normal force is the force a surface applies to an object to keep it sitting on a surface. Without a normal force, objects will fall through the ground because there will be nothing to hold them up. On a flat surface, this normal force is equal to the force of gravity acting down on the object, and this can be calculated by taking the mass of the object, obviously in kilograms, and multiplying by the acceleration of gravity. And with this formula is F equals m times g. Now I'm going to talk about the static friction formula, and I explained that static friction is a force that keeps an object at rest, and if a small amount of force is applied to an object, the static friction has an equal magnitude in the opposite direction. If the force is increased, at some point the value of the maximum static friction will be reached, and the objects will move. The coefficient of static friction is assigned the Greek letter mu, with a subscript s. The maximum force of static friction is mu s times the normal force of an object. In science, Fs equals force of static friction, mu s equals coefficient of static friction, the letter n is normal force, and Fs max is equal to maximum force of static friction. Now I'm going to explain the experiment that we made, and the objective of the PIA was to measure the coefficient of static friction between two surfaces, wood and another surface assigned by our professor. So as you see in the video, we used wood and a mass of 0.2 kilograms, 0.4 kilograms, and 0.6 kilograms. Now I'm going to explain the procedure. First, place the plane at the ground level and have the extreme A, and make sure that the extreme A remains fixed. The only extreme that can rotate is the extreme B, as you can see in the video. Second, attach the assigned surface to the base of the container, and we can stick it with glue, but we didn't do that. Third, place the first mast that was the mast of 0.2 kilograms that you see in the first minute, inside the container and put the container at the center of the extreme B. And the final step, very slowly raise the level of extreme B so that the plane passes through the different angles. And then we have to measure the angles and repeat the process 9 times more and record the critical angle for each repetition. Then we have to do the calculations that are the mu s, and that's it.